So fx is given, I'm writing the fx only. Fx is given a plus bx when x less than 1. It is equal to 4 when x equal to 1, and b minus ax when x greater than 1. Okay, so this is the thing, that we having effect a three things is given when x less than 1, when x less than x equal to 1, and when x greater than 1. So what we have to do, we have to find fx. Now we have given these things. Given is um, limit x tends to 1 fx. Okay, so when limit x tends to 1, fx equal to f of 1. F of 1 means this value 4. Okay, this things is given. So how we have to, how to do? First we'll find the limit fx x tends to 1. Okay, we'll find limit x tends to 1. Then we'll find the we'll equalize that thing. So first write down this one, solution. First we have to find the limit fx x tends to 1, limit fx. So let's find out the left hand limit. Left hand limit will be equal to limit x tends to 1 minus f of x. Okay, then now which function we'll use? We'll use this function a plus bx. Okay, because here x less than 1, so it is, we will use this function. So our fx will be limit x tends to 1. Our fx will be a plus bx. Okay, if you put the value, it will be a plus b into 1, which means a plus b. Then right hand limit is will be equal to limit x tends to 1 plus fx. Okay, limit x tends to 1 plus fx. So which function we'll use? We'll use the second, the function where x greater than 1. Okay, this b minus ax. So here it will be limit x tends to 1 b minus ax. So if you put the value, it will be b minus a into 1, b minus a into 1. So ultimately it will be b minus a. Okay, now one thing, it is given that in the question it is given that limit of fx equal to f1. That means limit of fx means what? Left hand limit and right hand limit. Okay, so that both value is equal to 1. equal to 4. As per question, as per question, limit x tends to 1 f x is equal to f of 1. F of 1 value means 4. Why? F of 1 means what? F of 1 means function when x equal to 1. When x equal to 1, what is the value function? What is the value of the function? 4. So f of 1 will be 4. Therefore, we will have two equations. One is this a plus b equal to 4. One will be a plus b equal to 4. Okay. One will be a plus b equal to 4. Okay. And mark this as equation like 1. Another one will be b minus a equal to 4. This is our equation 2. Okay. Why? Because this is left hand limit and right hand limit. Both value is 1. So then what we have to do? Then we have to just solve the equation. Just solve the equation. How to solve? If you solve this equation, if you add, okay, if you add these two equation, what I will get? I'll get a cancel. This will be add 1 and 2. Okay. From value of 1 and 2 will be 2b equal to 8. Therefore, b equal to 4. Okay. And put b equal to 4 in equation 1. If you put b equal to 4 in equation 1, we will get a equal to 0. Okay. Now, so a and b value we already got. That what we have to find. Look in the question. In the question is given what is the possible values of a and b. Okay. What is the possible values of a and b? That was the question. Now, now let's find out question number 29. Question number 29 is the important question. Question number 29. Question number 29 is saying a page number. Everyone, please open your book. Okay, keep open your book. Otherwise, it will be very difficult to. Otherwise, it will be very difficult to do. So, in question number 29 is saying let's a1, a2 up dot dot up to an be fixed real number. Define a function fx which is equal to x minus a1, x minus a2 dot dot x minus up to x minus up to x minus n, x minus an. What is the limit x tends to a1 fx? This question looks very complicated, but it's very simple. Let's write down the fx first. Fx is given x minus a1, x minus a2, continuation, multiplication, x minus an. Okay. So our first question, let's focus on first question. The first question is we have to find limit x tends to a1 of fx. So what will be limit if x tends to a1? How to do? We have to just replace x with a1. Okay, in this limit. Fx means what? Fx means this one. So it will be a1 minus a1. It will be a1 minus a2 dot 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 a1 minus an. Can anyone tell me what will be this value? What will be the product? You can see a1 minus a1 into a1 minus a2 continuation a1 minus a. Okay, so I hope the limit you understood what the limit question asks. The question limit here asks that suppose one limit is there, that is fx equal to x minus a1 x minus a2 continuation of x minus a. Just this is a function of it. Okay, now the question is asked, we have to find limit x tends to a1. The x tends to a1, how to find the limit? We have to just replace the x value with a1, right? To do so, I already wrote this function. Now I'm asking what will be the answer of this? What will be the product of this? Let me know the answer. 1 minute I'm giving you time. What will be answer of this one? Let's see, anyone. Is the question is clear or having doubt? Let me know first. Am I audible or not? Am I audible? Let me know. Am I audible or not? Still no response. I can see. Okay, one response I got. Okay. Okay, fine, fine. No, my question is clear. This is so easy question I asked actually. My question is here you can see one multiplication is there. How what will be the answer of this multiplication? That's only the simple question I asked. What will be the product of this multiplication? Class 7 8 standard question this is. Okay, no response. Let me know you understood this line. Did you understood this line? Why I wrote this line? why I understood, why I wrote this line. How many of you understood this line? Otherwise, there is no, I mean, I'm doing one things and you are not responding. Not a good things. Let me know. How many of you understood the yellow highlighted part? Or if having doubt, you ask me. Okay, fine. So can't you say the answer? What will be the answer? I don't know what to do. Look at this question. In this question, you can see here a1 minus a1. So what will be the value? Here will be 0 into all these. So 0 into all this will be what? All the value will be 0. Such simple things. If you can't answer, I don't know how we'll do the question later. Because this limit delivery very much practice purpose. Okay, if you don't practice, and the question I asked, actually this is not for practice even. This is like a very basic thing. Okay, next question was saying, for some for some a not equal to a1, a2 up to an. It's saying a is not equal to a1, a2, a3, like this. Okay, we have to find we have to find we have to find limit of we have to find limit x tends to a. We have to find limit x tends to a fx. So how to do this limit? Fx, just put the value x tends to fx is x minus a1, x minus a2, multiplication x minus an. Okay, now in this one we have to directly put a. Okay, so if you put instead of x, we will what we will get? We'll get a minus a1, a minus a2, continuation a minus an. Okay, this we will get. Now here it is given a not equal to a1, a2, an. Okay, so this value will remain same. This is one of the most easiest question. This looks very complicated, but it's so easy question. Fine. But next question is very important question. Next question we are going to do, that is very important. If anyone having any doubt, still the time, you can ask me now, because question number 30 is extremely important question. My goodness, Sangeeta is joining so late. Okay, just to inform you, I hope all of you remember I already gave you the routine for Eureka classes, right? So today class was from 10:30. Okay, so please keep in mind. Understood? you have only one class in a week, which class is 10:30 to 11:30. Understood? Some of you are came very late. I thought you made the mistake, so be careful about this one. Okay, fine then. Mhm. Let's though I'm recording the class, but still. Question number 30. Question number 30. Make sure everyone have your book open, page number 312. Question number 30. First, I'm writing the fx. Whatever the fx we given, I'm writing the fx. Fx equal to given modulus of x plus 1 when x less than 0. Then equal to 0 when x equal to 0. And modulus of x minus 1 when x greater than 0. The function is given, this function, three values is given: when x less than 0, when x equal to 0, and when x greater than 0. Okay, the function values are given. We have to find for what value or values of a, limit x tends to a will exist. We have to find limit x tends to a, fx will exist. Okay, will exist. You have to find values. Now here very important thing is that check this one carefully. Here it is given x tends to a, right? Here it is given x tends to a, and look here, no a is given. Understood? That means we have to take all the possibilities for a. Understood? Suppose this question is given x tends to 0 or x tends to 2 or minus 5, so that we can easily go to the question. But here it is given a. That means we have to take all the possibilities of a. Okay, a can be a positive number, a can be a negative number. Okay, like that. So we have to take all the possibilities for a. Okay, when a can be 0, when a can be negative, all the possibilities. So i'll start with when a is positive. Okay, let's start the question like this. Solution. Case 1. Case 1, when a greater than 0. Okay, when a value is positive, therefore left hand limit. Okay, start with negative, not positive. Start with negative. No problem. When a less than 0, so left hand limit will be equal to limit x tends to 0 minus fx. Now which fx we will take? Let me know which fx we will take. Which fx we will consider? Anyone? First, which fx we will consider? You can see there are three values of fx are given. Now it is given that a is less than 0. So which fx, which function of x will we consider? First one, second one, or third one? Please reply. got one imply, yeah, modulus of fx, sorry, modulus of x plus 1. Why? Because here x less than 0. Okay, so here we have um, it will be limit x tends to 0 modulus of x plus 1, right? Modulus of x plus 1. Now put the value of 0, put the value, sorry, I made one mistake, just wait a minute. It will be, it is not x tends to 0, it will be x tends to a. Okay. Why? Because look, a we already took less than 0. Okay, so it will be a x tends to a minus, it will be x tends to a minus. Okay, now my question is, next, limit x tends to a, what I will write here, modulus of x equal to, will write minus x. Why? Because when x is less than 0, okay, if x is less than 0, negative, that means modulus of x will be negative. Okay, if x is greater than 0, then that time it will be positive. So if we just put the value a plus 1. Okay, now right hand limit equal to limit x tends to a plus, okay, of fx, which is equal to limit x tends to a plus. Now tell me which fx will use. We have to find right hand limit x tends to a plus, which limit will use, first, second, or third? First, second, or third, which limit will use? You can see here x less than 0 this, x greater than 0 this, and x equal to 0 this. Here we took x a less than 0. Okay, so limit x tends to a plus, which limit will use? First, second, or third? Okay, 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 everyone tried good, but here we'll use the first limit. Why? Because you check, we already took a less than 0. A less than 0 means what? It is negative side. That means we have to take, for all this case 1, you have to take the this limit. Okay, that is the tricks here. That is the one trick we here is given. So we have to use this limit x less than 0. Okay, so many students did the mistake, so that I told this is important question. So we'll use x modulus of x plus 1. Why I'm using, again I'm saying that here we already took a is less than 0. Okay, I told the, we'll consider three cases: a less than 0, greater than 0, and equal to 0. Check. So when a gets